Hello and welcome to the Graphing Exponential Functions video. In this video, we're going to cover graphing exponential functions using transformations. I'm only going to be doing one problem because I feel like we spent so much time graphing with transformations that it's basically the same thing with exponential functions. It's just that the function looks different. So an exponential function in transformation form looks like y is equal to a times b to the x minus h plus k. In our case, b is going to be our base and help with our parent function. Now, for our unit, we're only going to use two bases. We're either going to have the base or parent function of 2 to the x or 1/2 to the x. So it's either going to be 2 or 1/2. That's not something we're going to need to find. But that deals with our parent function. A, that is our stretch, so we've dealt with that before, that multiplies to our y values. We're also going to start calling that our scalar. So that's going to be a new vocab word, scalar. But this is our stretch, and it applies to our y values. And then keep in mind that if this is negative, then it's a reflection, meaning it reflects over the x-axis. Our h is going to be our horizontal shift, meaning it shifts to the right if we have something like an x minus h, or it's going to shift to the left if we have an x plus h. And then lastly, that k is our vertical shift, and it'll shift up if we have a plus k, or it'll shift down if we have a minus k. So again, the a, h, and k we've dealt with before. The only new thing is that we're now going to call a our scalar, and that the b right here is going to be our base, where we find our parent function, and that's either going to be 2 to the x or 1/2 to the x. So in the example we're going to do, we're going to use 2 to the x, and our function is going to be, I'm actually going to move this up, so make sure you have this written down. We are going to be using f of x is equal to 4 times 2 to the x minus 2 plus 2. So what we have right now is that this 4 is our scalar, or if we were to write it the transformation, that's going to be a stretch by 4. And again, remember that applies to our y values. Next, we're going to have in our exponent, that's our h. We don't have to worry about the base yet. We'll get to that in a little bit. But that's going to be our h. And that's going to move us to the right 2 units, because that's a minus 2. Remember that affects our x values. And then lastly, we have that plus 2 at the very end, moving us up 2 units. And again, that affects our y values. So that's our list of transformation and what they affect. Now, when we make our transformation table, that's when we look to the b, or the base. So in this case, we're going to be using the parent function of 2 to the x. There we go. So if we're using 2 to the x, whenever we're dealing with exponential functions, regardless of the base, we're going to use the x values of -2, -1, 0, 1, and 2. And we're going to plug them into this function. So if we take 2, we plug it into here. 2 to the power of 2 gives us 4. 2 to the power of 1 gives us 2. If we plug in 0, anything to the power of 0 gives us 1. And then just remember, if we put in a negative exponent, it becomes a fraction. So 2 to the -1 becomes a 1/2. And 2 to the -2 becomes 1/2 squared, or 1/4. So this is what the parent function looks like for 2 to the x. And now we have to apply our transformations. So I can see my x values, the only thing that applies to the x values is moving right 2 units. So I'm going to add 2 to all of my x values, since we're moving to the right, and we'll get, let's see, 0, 1, 2, 3, and 4. I'm done with those transformations, so those are all my new x values. Then for my y values, first thing I'm going to do is I'm going to multiply everything by 4, since that's our stretch. So that's going to be 1, 2, 4, 8, and 16. And then I still have to go through and add 2 to everything, to all my y values, excuse me. So when I add 2, I get 3, 4, 6, 10, and 18. Then I'm done with my transformations for the y values, so there they are. Now I'm going to pause this video to bring up the blank graph. Alright, so I think that just magically appeared for you, but we now have the graph up. I think it's a little bit crooked, but I can't figure out how to fix that. I am sorry. But basically, when we are graphing, one thing we need to know when we're graphing exponential functions is that they do have asymptotes, and it's all based on that vertical shift, or moving up or down. So since we moved up 2 units, it means that we are going to have a horizontal asymptote when y is equal to 2, and we'll cover that a little bit more in the next video, but I just want to make sure I don't graph over that line. When we graph our points, we're going to have 0, 3, 1, 4, 2, 6, 3, 10, and 4, 18. Oops, sorry, that last point is incorrect. 4, 18. There we go. Now that looks much better. To make sure to connect all of your points and make sure not to go over that asymptote. But there we are. That's one whole problem, graphing exponential functions with transformations. Please do watch this video if you need to, and make sure to watch writing exponential functions, the writing exponential functions video, which is coming up next. Let me know if you have any questions. I look forward to seeing you in class.